Hi, I'm Patrick Heath, Product Marketing Manager at Microchip Technology for Motor Control. The Field-Oriented Control Algorithm, or FOC for short, for BLDC motors provides the advantages of higher efficiency, lower cost, quieter operation, and maximum torque response over a 6-step commutation. However, there are many challenges to tune the FOC algorithm to work with a particular motor. The FOC algorithm is dependent on motor parameters like the motor stator resistance and inductance, the back EMF, and other mechanical parameters. Many times these parameters may not be available in the motor's datasheet or are inaccurate due to the effects of the feedback circuits on the control board or changes as the motor heats up. Because of this, it can be very time-consuming to hand-tune the FOC algorithm for your specific motor. In this video, we will show you how our latest motorBench development suite, a GUI-based software development tool, supports the DSPIC motor control digital signal controllers. This tool reduces the time required to run your motor with FOC to just a couple of minutes. This tool is especially useful when the motor parameters are unknown. With the help of the motorBench development suite, you can accurately measure and report a motor's electrical and mechanical parameters. You can quickly get stable, proportional integral control loop gains for velocity, flux, and torque. You can visualize how the control loop gains affect your system through Bode plots and adjust these if necessary. Once the 3 PI control loops are tuned, you can auto-generate code straight into an MPLAB X IDE project to run the motor. The motorBench GUI has integrated help information to guide you through the motor identification and tuning process. To reduce your learning curve, the motorBench development suite is integrated into the MPLAB X ecosystem and is available as an MPLAB X IDE plugin within the MPLAB code configurator. It works in conjunction with Microchip's motor control development tools like DSPIC-DIM MCLV2 development board for low voltage motors, DSPIC-DIM MCHV3 development board for high voltage motors, and the DSPIC33EP256MC506 external op-amp motor control PIM. For today's demo, we will use the DSPIC-DIM MCLV2 development board with the DSPIC33EP256MC506 digital signal controller based external op-amp motor control plug-in module, and this 24-volt, 3-phase brushless DC permanent magnet Hurst motor. To spin a motor, you just need to follow these 5 simple steps. First, create or open an MPLAB X project for motorBench. Launch the motorBench development suite, which is a resource within the MPLAB code configurator. With the help of the motorBench tool, accurately measure your motor's electrical and mechanical parameters. Let the tool auto-tune the 3 control loop gains. And finally, generate the source code to spin your motor. Now let me show a live demo of how our motorBench tool simplifies spinning a motor. Before we start, please make sure you have the latest MPLAB X IDE, XC16 compiler, and MCC plugins installed on your system. The motorBench tool is available as a resource within the MCC. First, download and open the sample MPLAB X project for motorBench by visiting www.microchip.com/motorbench. Right-click on the project and set this project as the main project. Before you proceed any further, right-click on the project and configure the project properties. Select the XC16 compiler and the debugger connected to your MCLV2 board. Now, launch the MCC to open the motorBench tool. If the motorBench Composer view doesn't show up, double-click on the motorBench development suite from the device resources to add it to your project resources. At this point, the motorBench window will request you to complete the registration when used for the first time. For registration on an offline machine, please contact motorBench support at microchip.com. Once you complete the registration, you will get to the home page. You will navigate between the configure, tune, and customize stages as you progress. In the configure stage, click on the import motor button to select the PMSM motor and the Hurst template motor. This will load the default motor values such as the number of poles and the maximum motor speed. If you are using a different motor, then you will need to edit the motor details as per your motor's specifications. The new details can be saved by clicking on Export Motor to save it to a new file. Once all the parameters are configured, click on the Measure Now button to advance to the Measure stage, where the self-commissioning window appears. Before you begin the measurement, please make sure that you have selected the appropriate COM port on your PC. For this demo, we will skip the calibration step and proceed to measure the motor parameters by connecting the motor to the MCLV2 board and clicking on the confirmation box. The motorBench tool will run various algorithms at standstill and free running conditions as it measures the motor parameters. You will now start seeing the measured values appear on the screen and their puzzle icons change to the solved status. Once all the motor parameters have been measured, you can proceed to the next step of auto-tuning the control loop gains by clicking the Tune button. You can visualize the controller gains based on the default values of phase margin and PI phase lag at crossover using the Bode plots. You can also modify these values using the sliders as required for your system and see the effect. However, we recommend the default values of 80/45 and 65/10 for the current and velocity controllers respectively. The Customize stage allows you to alter the motor startup parameters that are measured and tuned by the motorBench tool. Finally, the solved puzzle icon will indicate you are ready to generate the FLC control code by clicking the Generate button. Once the code generation is completed, the source code files get added into your project. After successfully building the project, program the DSPIC33 DSC on the MCLV2 board and see your motor spinning with FOC. The generated code has a basic interface to start, stop, and vary the motor speed and direction by pushing the respective button or turning the pot on the board. Now that you have successfully spun the motor, this project serves as a good starting point for developing your custom application. The motorBench Development Suite offers you the following benefits. First, you can spin your motor in just a couple of minutes, even when the motor parameters are unknown. Second, you get the complete source code, allowing you to customize it per your requirements. And third, you can download the motorBench Development Suite absolutely free. To learn more, visit www.microchip.com/motorbench. That's all for now, and thank you for watching.